Welcome, listeners, to the Cyber GPT Pulse podcast. Your go-to place for staying updated on everything related to cybersecurity. I'm your host, Mohammed Ilyas.
I'm your co-host Sayyad Amaruddin.
Well, today we are diving into a crucial cybersecurity topic: supply chain IoT security, the world of Internet of Things, and its pivotal role in today's supply chain, uh, in the realm of Internet of Things, which is a critical evolution in both technology and logistics as well. As IoT devices become increasingly prevalent in supply chain, they offer numerous benefits like enhanced tracking, improved efficiency, and real-time data analytics as well. So, however, the integration also brings forth significant security challenges as well, in the automobiles, as well as in sort of any other IoT devices we are trying to implement and install it. So I have I just wanted to bring this question to you, Amiruddin. How can companies ensure that IoT devices being installed in their supply chain, like sensors, trackers, are secure before they deploy in any of the devices?
Yep, so that's a very pivotal and interesting question. And from perspective of any company dealing in IoT, need to first start thinking about the inventory analysis as well as the SBOM, which actually sometimes helps into identifying the application as well as the devices which are being used for various IoTs. So in a infrastructure or in automobile company, this can be from a few thousand to a million, uh, and it's actually ever growing. So the first step as for application security is always the asset identification. Same goes with the IoT. It's to identify the IoT entities, and then we can move forward for security checklisting, validating various essential controls like secure on communication, which is basically encrypted communication should be there, although it's kind of not always the case because of the limitation of the IoT. For example, for CAN bus in automobile, having encrypted CAN is subject to limitation of the device, of the infrastructure we are dealing with, because adding encryption to can be for a single car can be a few $1,000, but if you are scaling that to a million, then it's kind of a no-brainer that no company can actually practically do that. So that's first thing need to be done. Can we go for the encrypted communication or secure on communication, or sometimes there can be the trusted chain of identification. So that's first step. And apart from that, that's the next thing which always useful to check for is uh, no hard-coded passwords should be there on IoT devices. And then so prompting for the security patches from vendors, it's kind of very quintessential, but how to do that? uh, the patch release can have the latest update to the various series or zero-day attacks, which are been dealing with the industry. So those are important to be patched. But field or in the infrastructures industry, it's one of the ways is to do is using OTA or secure update or secure software update, and that's actually update the firmware analysis. It's kind of a similar thing like the Chrome update. One of the Chrome new version with the critical update is there, you will be prompted, but even if you are not updating it, it will be automatically updated. But in case of OTA, it's not exactly not the same, but yeah, you will be prompted. And if you are in the same Wi-Fi as same trusted Wi-Fi which has been trusted by the vendor, then you will be finally getting the update. Although this is OTA is not essentially developed for security. It's usually used for the new feature updates or some new dealer related news, but it can be also used for security updates depending on the requirements. So yeah, lastly, it's also when testing the devices is always great to know and also make the product team understand which of the attack scenario is more critical for the architecture, and based on that, visibility of the traffic uh, through device logging or on device logging, or maybe you are offloading your logging on cloud, but that decision need to be taken based on the attack metrics.
Well, that's an interesting perspective, I would say, from the OTA standpoint. Uh, I would like to add a few things to it. Like OTA updates are a great solution when problems arise, but scale and speed make bulletproofing when you have a hardware and software development practices critical to a
Yeah,
successful program. So by keeping the current technical complexity in mind, and so much is at stake as of now. So here are so I would like to recommend few of the safeguard systems that can minimize bugs before OTA deployment takes place. So we all know that they don't come as a single simple solution wrapped in neat box ready to be deployed. Because of
yeah,
this criticality, it's important to focus on the underlying systemic infrastructure that can deliver your software along with appropriate process, and check that verify everything works as it should be under any circumstances. In fact, I agree. Like there are a great number of activities need to be in place to have it effective OTA program. Like let's say if, there are the most important three categories OTA deployment takes care is like robust public key interface is the one, and well-defined software verification process, and then
yeah,
the effective, if it's in a vehicle, then effective vehicle software development, storage, and activation is another important thing
yeah,
I would recommend. So yeah, so
yeah, yeah.
now
On that point, I would just like to add that those are the next version which you actually presented thing, and next update in the automobile sector, and with PKI finally being inculcated as a trusted mechanism, we can finally have these challenges handled in better ways.
correct. Well. Now for our listeners, so what protocols? Could you explain, like, what protocols are best suited to securely transmit data from IoT devices which are used in the supply chain?
So it is a tricky question actually. So the best suited algorithm should be the same one which we use in web application, but whether they can be actually used in the limited resource constrained environment of IoT, that's the big question. So that's why we usually see the MQTT protocol that was actually essentially developed for satellite communication. So that's the first one, and second one is AMQP, which is essentially the Kafka does use for ingestion and data streaming. So these are the two most popular ones and most common one which are being used in the infrastructure. But it need to be also coupled with SSL, or at least some certificate management. Usually it's SSL or TLS, which is incorporated with these protocol, and these provide the secure data in communication. And for storage, there can be multiple solutions based on, again, it's need to be determined by the security architect and the designer of the system. But one of the more famous solution, or I should say more interesting solution, is blockchain protocol using the hyperledger, providing immutability and prudence for IoT data, prevents tampering. But essentially, it's depends on the industry. Like in automobile, it's more secure boot or firmware. This firmware where secure boot is essentially the boot loader is being secured in such a way that whenever if a boot is done, that firmware signature is been mapped or is been matched. If it is failing, then it won't load. So these kind of storage mechanism is being used by various industries. So it's actually subject to industry, uh, which mechanism or which process is more suited to.
Well, that's fascinating as we delve into the supply chain's IoT security. So, what do you think? How can companies restrict damage if their supply chain IoT devices gets infected with malware?
So essentially, need to start with the threat assessment and damage scenarios of that industry, and whether the industry is more subject to external damages, like on field there could be in field disruption, and those disruption need to be first avoided. So generally, we can say that the similar network solution is having the network segmentation of these IoT devices and IoT networks, and those essentially helps to stop the propagation of any malware or any malicious actor. And other controls can be monitoring the device traffic, although monitoring the device traffic is more often done from the cloud server or the backend, and that need to be also taken care. The log which is been sent to the backend, that need to be securely communicated. If that has been cut on, maybe, or that log has been somehow maliciously tampered with, then you won't never know that if there is some kind of actor or some firmware uh, tampering has been done on the device. So these kind of trade-off which need to be taken care of, and also keeping the patch is the most important thing, and it's more likely a issue, not if not more than at least at the same threshold as we have in the web applications. Uh, the retirement, the retired version is more likely being used in the legacy devices, and we still have those end of life devices in the field. So those need to be also patched regularly, and that essentially mitigating the higher risk.
Well, thanks for breaking that down. So, shifting gears a little bit now. So, with more companies requiring IoT devices in supply chain, so can you can you help understand the standards and governance model should they adopt to ensure minimum security levels?
Yep. So again, it's depends on the industry you are talking about. Like um, for automobile, it's ISO 21434, and if you are talking about any other industry, generally the IoT security foundation framework does help to identify the alignment to ISO 2702 or UL 2900. So these essentially focus on the device lifecycle consistency, and these governing bodies does provide the policies, control, best practices which need to be followed.
Yeah, you're absolutely right. When I was working for on one of my projects, I did work with the NIST risk like GRC. So I was working on ISO 27001 compliance life cycles, and I had to adhere by something in the cloud. So yeah, that governing bodies definitely needs to align and include their life cycle process that really that really helps make the security worthwhile and more strong from the from the compromising perspective. So yeah, that's a great advice though. And can you certainly help understand uh, what additional challenges exist in securing electric vehicles? So, with larger digital attack surface due to connectivity and enhancing battery management, And also, let's say, like, because currently we are slowly moving towards EV from the gasoline vehicles. So what about the power efficiency in EV charging systems?
So yeah, not amount to limited to EVs, but API security is one of the predominant channel which we see in cars, automobile sector. So that is one of the main challenges in EVs, as we have the near field access to various functions in a car. We will be having those APIs calls being governed on and having those increased number of tokens, and with the again the limited storage and resources, these storage of API tokens sometimes is on device, and if you are storing it on device, then it can be leaked, or essentially it's actually increasing the various ways of being leaked. So that's need to be first model. And yeah, apart from that, the third party public charging station are also similar to also having the risk similar to the third party vendors which we have in application security. And also the unsecure connectivity which we have to do for EVs, moving around for home network to the dealers network, sometime in the charging network. So essentially you will be having this access point moving around from one point to another. So how to secure to do to that? Yeah, so we know that there are been Tesla attacks, as well as the recent RAV4 attack, and recent RAV4 attack is was essentially using a JBL, a J, morphed JBL Bluetooth speaker to connect into the CAN communication, essentially to unlock the car. So it's kind of the detail attack. If anyone wants to know, then I will just put into show notes. But it's kind of one of the interesting attack which you can understand that having the car locked is even though your key fob is in a Faraday box or in constraint box, even then you can have your car being hacked. So like for RAV4, the solution they proposed was finally using some iron pellets to cover it in more defense in depth sort of thing, because the solutions of secure on communication is much more expensive with the callbacks of these cars. So yeah, that's the more so essentially with EVs, this problem or this attack surface and with various vendors risk will even increase.
Well, that's fantastic thing, recommendation you have brought it up. So so before we wrap up, I just got another quick question. So the compliance standard, as you mentioned, like there is a UNECE WP.29 and ISO standards as well, which are aiming to provide cybersecurity regulations for the auto industry. So can you like shed some light on how OEMs prepare for this, to drive better security across the automotive ecosystem?
Hmm. So, uh, so yeah, although these compliance and regulations are there, but depending on the maturity of OEM, what from my own experience, they are still lacking behind. So, from the manufacturer or the companies which are using these components from OEM need to have their own investments into threat assessment, design model, the design assessment of the architecture for defense in depth, establishing their own detective program from basically secure by default or secure by design. These are very interesting. These are very more interesting controls and techniques which need to be done by the manufacturer themselves, cannot depend on OEM. Although OEM assessment is also critical, uh, they need to be assessed based on their own threat matrix, but the companies which are using the services, they have to have their own simulation model to evaluate the risk they are integrating with these vendors or these OEMs. So we are at the, specifically for automobile, we are at this level of maturity. So yeah, you have to have the contingency plan for various attack techniques, and have to have the like for one of the thing which I always ask to any OEM analysis, with what is the data flow. So what kind of data types will be storing anywhere, if you are using any S3 bucket, or maybe um, you are using AWS IoT. So are you using a device defender? So if there is, so what are the monitoring controls you are using? So these type of questions need to be asked, and essentially making your own threat modeling is the way forward.
Well, exciting developments. We are looking forward. So, yeah, thanks so much for sharing your valuable insights and expertise with us and to our listeners. So, buckle up as we embark on a journey through the cyber realm, uncovering the threats and opportunities that lie ahead. Don't forget to subscribe, because the Cyber GPT Pulse podcast channel electrifies your cybersecurity knowledge. So, well, that's all for this week.